Today we are going to talk about how VMware IT is using NSX Firewall for micro-segmentation planning and troubleshooting. My name is Sukhjit Singh, and I am here in VMware working as a senior network services administrator. Here in the team, I am primarily planning and architecting VMware NSX Advanced Load Balancer along with NSX IDFW firewalls. And as a part of network and security services team, we are here managing various network services, for example, DDI authentications. And today I'm joined with my colleagues Stanley and Neha. Stanley, over to you.
Hey, Sukhjit, thank you. Hello, everyone. This is Stanley D'Souza here. I've been working with VMware for the past 5 years, and I've been part of the network and security services team. And I've been working on various core services as part of this team, like DDI, IPAM, DHCP, NTP, and other services. I also have been working with F5 load balancers and micro-segmentation, NSX micro-segmentation. In this journey of VMware, I have been with various projects like migrating F5 load balancers to NSX advanced load balancers and also micro-segmenting applications. Over to you, Neha.
Thank you, Stanley. Good morning and good evening to all. My name is Neha, and I have been working in VMware for the past 4 years as a network and systems administrator. As a member of network and security services team, I work on core network infrastructure services like DNS, DHCP, IPAM, load balancing, NSX distributed firewall, wireless NAC, and I'm also part of VMware on VMware initiatives like F5 to AVI migration and NSX-V to NSX-T migration. Okay. So as an IT administrator, there'll be challenges on how to prevent security breaches. A fundamental aspect of addressing this problem is implementation of NSX network micro-segmentation. So VMware NSX distributed firewall can be used to implement network micro-segmentation at a minimal cost. Let's look at the approach in traditional perimeter-based security versus application-level micro-segmentation. The traditional perimeter-based security relied primarily on the perimeter defense, securing the north-south traffic, but assuming that the east-west traffic in the data center was safe. Thus, the traditional approach can cause few security issues. NSX distributed firewall is an approach that provides enforcement at the most granular level, right at the VNIC of every virtual machine, and specifies the flow, what should be allowed between two entities. Moving on to the logical network topology, let us take an example architecture where we have two departments, finance and HR, and each department have a web, app, and a DB VMs. The logical network topology has a perimeter gateway that leads to a distributed logical router, which in turn has three logical switches of web tier, app tier, and DB tier for the departments of finance and HR. NSX distributed firewall is an approach that provides enforcement at the most granular level, right at the VNIC of every virtual machine. So here we can secure the east-west traffic filtering in the data center. With NSX distributed firewall, we can now group this topology into 6 security groups. A logical group each for app and DB VMs for the departments of finance and HR. Let us look at how NSX distributed firewall protects inter-tier and intra-tier traffic. In inter-tier traffic protection, traffic is monitored in a close-knit network. The inter-tier traffic from the user to the web tier, that is the HTTP and HTTPS traffic, is protected by the distributed firewall. Traffic on port TCP 1234 and SSH is allowed from web tier to app tier. And similarly, only MySQL-based connections are allowed from the app tier to DB tier using NSX distributed firewall. In intra-tier protection, traffic protection, traffic is allowed between the virtual machines that are within the same logical group of the switch. Like here we can see ping is allowed within the VMs of web tier. Physical topology and components. Here we have compute cluster A, compute cluster B, management and edge cluster driven by the management network L3 and VXLAN transport network L3. Here the logical topology is completely independent of the physical topology. Now let's look at how we had micro-segmented a complex application called SAP in VMware IT. SAP consists of many components that are used for different purposes, a few of which are listed over here. In a scenario where SAP is without micro-segmentation, every VM will be able to connect with every other VM. And also all the services will be allowed by default. For example, a monitoring server can establish connection to any of the VMs which are inside the firewall. When we microsegment SAP using NSX distributed firewall, each VM will now fall into its own perimeter. Policies are aligned with the logical groups and any unauthorized traffic gets blocked right at the VNIC level. The first step in microsegmentation would be placing the VMs into a logical group, which is basically the creation of security group. Here we have a view of the security group topology for SAP systems. The app VMs of each sub-application of SAP are grouped into a security group, and similarly, the DB VMs into a separate security group. Here we are making use of nested security groups to club all the security groups created for app and placed into SG SAP app, and similarly for DB SG SAP DB. Finally, at the top level, we have a master nested security group created, SG SAP all, that combines the two nested security groups. Once all the security groups and nested security groups are created and are in place, our next step would be application discovery. For achieving this, we would need to enable logging. We need to create a security policy with a firewall rule defined to allow all the traffic to the VMs that are part of the nested security group. And the NSX manager will forward all this traffic logging to VMware vRealize login site, which can be used to analyze the flows and sort out only the required and authorized flows. Next, we are going to talk about application discovery using flow monitoring, which Stanley will be taking over.
Thank you, Neha, for the informative walkthrough on micro-segmentation. So let's begin to explore how we can make our micro-segmentation journey easier. Wouldn't it be wonderful if at all we click a button and applications get micro-segmented? That's not true in a real-world scenario. To discover application workflows, VMware has different tools available, and one of the tool is a login site. A login site provides intelligent log management for infrastructure and application in any environment. We have been using login site in our journey a couple of years back when we were doing a lot of manual efforts. But we have evolved from there, and we have been using another tool from VMware, which is Login Site, which is a network. vRealize Network Insight. So vRealize Network Insight gives us a 360-degree network visibility and also analytics. It also gives us what's the best practice, the health and availability of NSX deployment. vRealize collects inventory from various physical sources like switches, routers, firewalls, and load balancers, and so on. It also gives data, collects data from different environments like the virtual environment and cloud environment. It puts the data together and puts it in a good use in gaining visibility into our complete network constructs. With the help of machine learning, it constructs meaningful insights. It also gives us a broader view of how systems are dependent on each other, what systems are shared, and where are the systems running on our environment. Let's focus more on how we can use vRealize Network Insight for our micro-segmentation journey. Here we use vRealize Network Insight to discover our network, the data what we have gathered using vRealize Network Insight. And using this discovery process, vRealize Network Insight will give us a recommendation. In the previous slide, when we spoke about the login site, we used to manually go ahead and understand the application workflows. But with vRealize Network Insight, it would be automatically giving us recommendations. Let's go through a quick demo and understand how vRealize Network Insight, how we can leverage vRealize Network Insight for our micro-segmentation planning, for governance, and troubleshooting. So let's log into vRealize Network Insight using our AD credentials. Once we log in, we can see a dashboard. This dashboard gives us a lot of high-level information on our infrastructure. Here in this demo, we'll be seeing how we are going to plan, how we are going to do governance, and a little bit of troubleshooting, how Network Insight can be used. Let's click on Security, go to Applications tab. Here we can see a lot of applications has already been discovered by our vRealize Network Insight. And it has gathered all the information like drop flows, tiers, VMs, and other details. Let's go to the Discovery Application tab. And here we will be using tags or names to discover our application within our environment. We can also discover based on groups for using the regular expression. In our environment, we have very strictly maintained the naming convention. And this helps us to use the regular expression to gather the data and to discover it. Let's do a little plan of the security and also try to understand how vRealize Network Insight will give us the recommendation. For our demo here, we will try to see the discovery of one of the application called the eTracker. We will try to discover for we can use 1 day or 7 days or 30 days. For our demo sake, we'll just go for 7 days of discovery. Once we click on Analyze, it will go ahead and gather all the information related to the eTracker and give us a very informative visualized information. It also shows us how the traffic is flowing from one tier to another tier, how the systems are communicating. It also shows each and every incoming and outgoing traffic. We can go ahead and look into the area of interest. And when we click on one of the systems, we will be able to drill down on other information particular to that system. Here it gives us more detailed and granular information like what are the flows incoming and outgoing. It also gives us a recommendation. If you look here, it has provided us 33 firewall rules. These are the recommendations out of its learning. So these rules, if at all you look at it, we can see that 8 flows have been captured here. And by default, it sets the rule to any, and all the rules are allowed. This is just a recommendation. Once we include our micro-segmentation, we have to go ahead and click on the drop, and then we will be able to implement micro-segmentation on this eTracker application. So this is more about the planning. Let's go ahead and see how we can do governance using Network Insight. When we click on settings, we will be able to see system events. Here, there are a lot of pre-built system events already. We can go ahead and customize a lot of system events, or we can use the inbuilt pre-built system events. We can have events like firewall rule membership change or property changes of any firewall. This will trigger an alert whenever there are changes or events captured. So this is more about the governing, how we can enhance our systems with governance. Let's look about how we can do troubleshooting. When we click on path and topology and go to the path, we will be able to have an option where we can feed in the source. Here we can give an IP address or a system name. We'll give a web tier as our source and the SQL as our destination, and just try to quickly understand how it will give us the flow of the traffic. Here you can see in a visualized representation how the traffic is flowing from the source to the destination. We can also try to see the other way around, the traffic flowing from the destination to the source. We can see a small icon here. When we click on it, it gives us a more granular information on the security policies, what have been applied. And when we want to further troubleshoot, this information comes in handy, where we will be able to see if there is a drop in traffic, then we can understand that it is because of the firewall rule being implemented. Then we can go ahead and allow it. This is more about how we can use Network Insight for our planning, governance, and troubleshooting journey. Let's look at another tool now, which is vRealize VMware NSX Intelligence. At its foundation, VMware NSX Intelligence is a distributed analytical engine. It's built and managed natively within the NSX. It empowers the network and the system administrators to deliver a more granular security posture. It simplifies the compliance and proactive security. With bidirectional intelligence feed from external sources like vRealize Network Insight or App Defense, and many more other tools can also be integrated with NSX Intelligence. It eliminates the need of a very large, complex, and centralized security analytical tools or network analytical tools. And um, NSX Intelligence, with its distributed analysis, it distributes all the analysis to its hypervisor. With this, it sends the relevant metadata, which are very lightweight, to the centralized repository. And based on this, it builds machine learning modules and future analytics. We can have a data center wise visibility and gain deeper understanding and insight about our network infrastructure. We can also understand the stateful layer 7 inceptions. We can go through the traffic flows, consolidated metadata, and complex content of related workloads is gathered within the NSX Intelligence. With all this data, what this tool does is it provides us a firewall policy recommendations. These recommendations can be used for our micro-segmentation. It also gives us policy enforcement workflows, policy compliance, and helps us in future design and taking decisions on how we can enhance our network in an overall perspective. The topology and workflow visualization is a feature which I use, and I love to use it when I'm working on NSX Intelligence. It gives me a very good detailed information of any application. It helps me to visualize how the applications are communicating with each other, how different systems are communicating with the applications. Let's go through a small demo and understand how we can use NSX Intelligence for recommendation and use it extensively for our micro-segmentation journey. So let's log in to our NSX-T appliances. Here, once we log in, the dashboard gives us a very detailed information, high-level information. But for the demo, we'll just go to Plan and Troubleshoot, and we will go to Discover and Take Action. Here, when we look at the information, it gives us a very high-level graphical representation of how our network looks like. We can further drill down into this graphical representation. But for now, for the demo, we'll just look at how we are going to get recommendation from NSX Intelligence. When we click on Start a New Recommendation, we will be able to give the recommendation name so that we can store it and use it in the future. We'll use here Colibra as one of our example. And when we choose more information, we can select here Colibra and get a security group, which we have already configured. And based on this security group, we will be able to pull the information, and NSX Intelligence will be able to give us a recommendation. Here we can ask for recommendation based on the objects or based on the IP. In our environment, we have a very good naming convention. That's why we would be using an object-based recommendation. And once we click on Start Discovery, it starts going into the data, what it has already collected, and processing the data so that it can give us the recommendation. When we click on the canvas and try to look at what data it is gathering, we can see that the application, the connected different servers to the application, we can see that there are different traffics flowing. Some are unprotected, some are allowed. So we can also granularly go even more deeper and understand how the traffics are flowing and communicating with the systems. Let's now go back to our recommendation and see whether NSX Intelligence was able to pull any recommendation. So it's still discovering the data. It's still because we have chosen 1 month as a time period, it's going deeper and trying to get more insight and more information out of the 1 month data what it has gathered. So we can to shorten the time, we can even click on 7, we can even go for 7 days, but here for our demo we are choosing 30 days of discovery. And now that we have the recommendations populated, we can go ahead and see that there are around 22 rules which has been recommended. We can either continue later, we can save this recommendations and come back and look into the recommendations later, or we can go ahead and proceed. Here we can see there are a lot of security policies which are recommended, and we can go ahead and either review them and delete what recommendations we feel are not needed, and we can also give priorities by moving them up and down. And once we are satisfied, we can go ahead and publish this right away from the NSX Intelligence into the NSX Manager. This is just a demo what we have. So we would not be publishing it for now. So let's look into Identity Firewall. I would like Sukhjit to take us through this Identity Firewall presentation. Sukhjit, over to you.
Yeah, sure. Thank you, Stanley. Those were nice demos. So when we talk about application and user identity firewall, or in other words, we can just say context aware firewall, right? So there is a context table, right, that keeps track of context attribute for every flow going through the distributed firewall filter. So here, every new connection is along with its context attribute is checked against the distributed firewall rule set. Okay, so this is just not based on 5 tuple that we are doing in the regular firewalls. This is also based on the context attribute specified in the rule. So when we talk about policy based on application context, right? So this is basically as 3, right? First is the network context where we have network 5 tuple or layer 7 ecosystem, right? So then we have the user context. We consider the user ID or remote desktop session host user sessions. And third one is the workload context. So where will be we having the OS name, OS, or what is the VM name, or if there is any VM tag or security groups are applied. So let's understand this as a 2 things, right? So when we broadly talk about, so one of them is application and protocol identification, whereas other is we can say that multi-session identifier firewall. So when we talk about application and protocol identification, so that is basically the ability to identify the flows generated by any particular application, which is independent of the port which is in use. So there we can have the visibility into the flows and enforcement based on the application identity. Okay, so deep packet inspection is the key fundamental here for this functionality. So it enables and matches the packet payload as per the signature defined in the built-in layer 7 service objects. So understand with this example. So let's see if we wanted to enforce based on port and layer 7 application ID. So let's take an example of one protocol, for example, MySQL, right? So we see that it is running on some standard port 3306, right? So if we are going to see that MySQL requests are coming on port 80, or if there is any other protocol which is sending the request on port 3306, for example, FTP, right? So we can identify the protocol and respective port, and we have the signatures for that. There we can block the unauthorized or which are not supposed to be seen on the network, right? Such communication can be blocked. In addition to that, we can also use this as to block the vulnerable application versions. For example, all of us are using the SL based web pages or applications, right? So there we can see that we have different SL versions being used. For example, TLS 1.2 and 1.1, 1.0, and SLv3, which is eventually we have stopped using because of the vulnerabilities and all. So we can also restrict our users to only use TLS 1.2. So that is how we can achieve the security with the help of application and protocol identification with the use of context aware of firewall. So when we talk about multi-user session identity firewall, right? So can you please move to the next slide? Okay, thank you. So there are few things that are the prerequisite to this condition, right? So for example, first we'll have to integrate our Active Directory so that we can identify the users based on the database that we have in the Active Directory. So we can just simply configure the user groups to identify if they are authorized to access the application or not. We have to enable identifier by going into the global firewall settings. And in the rules, we can just simply go ahead and define the application criteria. Here for an example, let's see, we all are using RDP connections, right? So to connect to our host. So let's see, there is an application, right, running on few servers, and users have to do the RDP to connect to those applications. So usually we have the firewall rules based on the tuples, and we have the IPs, right? But we have the users spread across the network. Some are using the VPN network, especially when they are doing the work from home, right? So we cannot just identify the user IPs, I mean, who are the authentic users based on their IP addresses, right? So there we can use this identity firewall to manage the user sessions. So we can identify the group of users, and we can configure that in the firewall rule. So whenever any authenticated user, authorized user is going to authenticate against the application, identity firewall is going to identify with the help of the packet inspection. And if that is the legitimate user, it is going to allow or block, right? So here we can use the identity firewall to fill the security holes in our network at a more granular level that we can say. And yeah, that's all about the identity firewall that we use here in the VMware. Now let's check the VMware approach of micro-segmentation. Over to you, Stanley.
Thank you, Sujit. So now let's look at how we can finalize policy creation, right? Our micro-segmentation journey begins with finalizing these high-level approaches. And policy creation has three different methods. The network-based, which is more of a policy, are very much network-centric. This is a traditional approach where we will be using groupings based on a layer 2 or a layer 3 elements. Here we can use either MAC address or IP addresses. This is basically not recommended in very high dynamic and complex environments, but still this can be used more in a static or a smaller infrastructure. So the next approach is the infrastructure-based. These are policies more of SDDC infrastructure-centric. In this approach, grouping is based on SDDC infrastructure like vCenter, clusters, or a login switch, or distributed port groups, etc. It is not recommended to use these infrastructure based in where there are no physical or logical boundaries. We can use infrastructure based on global policies like DNS or NTPs. This is a very good example for infrastructure based approach. For application based, this kind of approach or a policy creation is very much application centric. When I say application centric, I mean that we can group based on the application type or the application environment or application security posture. The advantage of this approach is that the security posture of this application is not tied either to the network constructs or the SDDC infrastructure. Security policies can move with the application irrespective of the network and the infrastructure boundaries. VMware recommends application-based and infrastructure-based policy creation approach. Next, we'll look at the security groups. The security groups is a container construct which allows to group vCenter objects in a common entity. We have dynamic inclusion where we can use OS names or computer names or say a security tag for a security group definition. This is basically recommended where there are very systems on a very large and complex environment, and if at all we have following a very good naming convention, then we can use application names to dynamically include the objects into the security groups. There is static inclusion and exclusion, which provides capabilities to manually include the objects into the security groups. These kind of objects are basically the clusters, the logical switches, data center, or MAC sets. So a security group are extremely important concepts because it can be leveraged very effectively when we are defining the DFW security policies or service composers. Now let's look at how we can operationalize. We have been doing micro-segmentation for a very long time, and based on our experience, we have put down a flow where we follow this within our organization. We see here, I would not be going into each and every block of it, but on a high level, what I would recommend here is to use the four concepts, which is the initialize, review, implement, and validate. Basically, when we want to bring a new application, we can just start an initiate request, and the same request can be reviewed by the security team and approve these policies. Once it is approved, the implementation team, which is the team which I'm part of, where network and security services, we will be reviewing the request, and we will be understanding how to implement it, and then create an RFC and implement it. Then we can go ahead and once it is implemented, then we can go ahead and validate the implementation of micro-segmentation. The next key thing out of our journey and out of our experience is the roles and responsibilities. As per the roles and responsibilities, it is recommended that NSX should be managed by separate teams according to functions. This is based on our experiences. Access should be limited based on the functionalities also, and NSX should be integrated with AD so that we have a very tight access to the environment. VMware does not recommend the use of root and administrator accounts and should be only used in emergencies with proper management approvals. We had many teams in our journey working on micro-segmentations, but over the time we have narrowed it down, and we have come down to these three teams, which is more than sufficient to operationalize micro-segmentation. And the first one is the vGrid team, which will help us in infrastructure administration. The second one basically is the network and security services team, which is our team, where we will be mainly our responsibilities would be for data security policies or creation of port groups or micro-segmenting the applications, and also troubleshooting these applications. when it comes to the micro-segmentation. The IT security team is basically an auditor's job, and they are the very key team where they would be reviewing the policies and allowing only the allowed policies within the organization. Let's look at how we can summarize the complete discussions what we have had for the past 40-45 minutes. And from our experience on implementing micro-segmentation over the years, we can conclude this discussion by understanding how we can achieve micro-segmentation in the real world. To begin with, we need to have a security fabric where we will be able to prepare the host for the micro-segmentation. Then we'll go ahead and do the application discovery. This is basically understanding from either our previous knowledge from perimeter firewalls, or we have tools like Log Insight or Network Insight or NSX Intelligence. We can leverage these applications to basically discover. Once we discover, we will be able to finalize the policy model. We will be able to identify the patterns and the flows of the application. We will be able to determine a policy a model based on the patterns, and we will be able to use this finalized model and apply the models to get the applications micro-segmented. Basically, this is overall summary how we can achieve micro-segmentation. Here are some resources for our VMware on VMware program. You can drop us an email at vmwonvmw@vmware.com. You can visit our blogs where we have the stories of our VMware on VMware journey. We also have our website for understanding what's our VMware on VMware program. And also you can tweet us or follow us at VMware on VMware. So I'll pause here for a moment so that you can take down the information.